Thanks to the Sustainable Business Council for having me here in Wellington. And of course, thanks to Victor for supporting this entire trip around New Zealand, which has been a fantastic experience to meet with all sorts of people on both islands, to see Christchurch for the first time after the earthquake, after I'd been there many times before, to go up into the Southern Alps. And that was a very interesting experience. But today I want to talk about climate change. Three different parts of the talk. The first part will be stuff that you probably already know really well. So I'm going to go through that reasonably quickly. It's what I sort of call standard climate change, basic climate change science, and so on. The second one is a sort of outsider's view with some knowledge, but of course not complete knowledge of what's going on in New Zealand, of what some challenges and opportunities are for New Zealand in the climate change space. The third part is quite a different look at climate change. It's in the context of the Earth system. And I think it's important because I find going around that everyone is tired of hearing about the problem of climate change. 99% of people actually don't understand what it is. And it's important that when we talk about solutions, we have to understand what we're trying to solve. And that's not well understood yet. So that's going to be the third part of the talk. So let me dive in with standard climate change science. You probably have seen this many times before. This is just a global average surface temperature record. And again, you can see from the mid-20th century how rapidly the climate system is warming. In fact, the last 2 years, 2015 and 2016, complete years, have been record hot years for planet Earth, much higher than anything that's gone before them. And there's no doubt whatsoever as to why that's occurring. There's a belt of greenhouse gases which are naturally around the planet in the lower atmosphere, and they have the property of trapping heat that's emitted from the Earth's surface and keeping some of that heat within the lower atmosphere and at the surface, and it makes Earth habitable. Without that, it would be 33 degrees colder and frozen all the time. So the natural greenhouse effect is very important for life. But as we pour greenhouse gases into the atmosphere, almost entirely now from burning fossil fuels, that belt is thickening quite quickly and quite dramatically, and that's trapping a lot more heat near the surface of the Earth, and that's what's raising the surface temperature. From a fundamental point of view, we can say that the energy balance, the balance of energy coming in from the sun and going out from heat, is now way out of balance, and that's because of the extra greenhouse gases. So it's a very fundamental problem for any planet, not just Earth, when their energy balance goes wacky. And of course, this is affecting us. That's why it's important. All of these images are taken within the last 10 years. They're from Australia, but it's not really unique to Australia. All sorts of extreme weather now, we have very good evidence, is being made worse by climate change. Whether it's heat waves, whether it's storms, bushfires, extreme drying across the southern part of Australia, all that now, we have very good evidence, is being influenced by climate change. But one of the things people don't realize, and that's because we're land creatures and we live on the surface with our heads maybe 1.5 meters to 2 meters above the surface, we don't realize that nearly all of the extra heat that's being trapped actually goes into the ocean. Only 1% goes into the air, 3% into ice, 3% into land, 93% goes into the ocean. That's really important for New Zealand because you're a couple of relatively small islands on the global scene, surrounded by ocean, and your climate is dominated much more so by what's happening in the ocean than the large continental climates are. And it's also extremely important, of course, for the marine biosphere. So this is the most complex and most beautiful marine ecosystem we have. It's a coral reef. It's a great barrier reef, in fact, between here and the Australian coastline, just right off the Australian coastline. But just in the last 2 years, we've had a massive bleaching event, 1 year after the other. Well over half of the Great Barrier Reef, which stretches for about 2,000 kilometers, the coral has gone from that to looking like that. Now, if we could cool the surface of the ocean or prevent any bleaching events for a couple of decades, this could recover. But in fact, because we've had 2 in a row and because they've been very severe, about 50% of the Great Barrier Reef now looks like this. It's dead. It won't come back. So a reef that's been killed has coral rubble down on the surface of the bottom of the sea there, but it's covered with algae. So it's actually a stable ecosystem. Very hard to flip it back from that. But this is a very impoverished ecosystem in terms of biodiversity and so on, and nobody wants to pay a lot of money to fly to Australia to go see something like that. So unfortunately, most scientists think that the temperature limit for the world's coral reefs is about 1.5. So the Paris 1.5 target is really important for a number of reasons, and in terms of the marine system, that's probably the biggest reason. You can see what's happening globally. We're actually seeing these reefs around the world just being tipped very rapidly as we watch them. This is a decadal count on the number of bleaching events right around the world. Before 1980, when temperature wasn't that much above pre-industrial, we had very, very few bleaching events. But look at those numbers escalating. It's a curve going like this. So just since the 2000s, we've had over 5,000 significant bleaching events on reefs around the world. So that's why, unless we get climate change under control really fast, this whole ecosystem is going to flip into an algae-based ecosystem. It's on the way now, unfortunately. Okay, what about New Zealand? I'll make a few comments about climate change and New Zealand. Well, the first thing is simply to look at what New Zealand's emissions are. And I have to say that it's a rather different emission profile because this is carbon dioxide equivalent. So this also includes the effect of non-carbon dioxide greenhouse gases, important for New Zealand in terms of gases like methane and nitrous oxide, which I'll cover in a moment. The point is the net effect on the climate from New Zealand is actually getting worse. In other words, there's more and more warming effect coming out of the New Zealand economy as time goes on. And contrast that with the United Kingdom, where emissions are going down quite dramatically. In many European countries, their profile looks like that. So there's obviously a challenge, and I really can't say anything in defense of Australia because our chart looks like New Zealand. Emissions from Australia are going up. Quite a different profile. Almost all of ours are from burning fossil fuels. Okay, this is a complicated table, so only look at this first column. This is an analysis of the pledges that countries made going into the Paris 2015 climate conference. And all this is doing is comparing the countries as to whether their targets they took to Paris are even closely consistent with the 2-degree target, the upper target. So if we look here, we can see that in general, the European countries, the EU, Norway, Switzerland, plus the USA, their commitments still allow the possibility of making that 2-degree target if they keep moving vigorously post-2030. But when you look at Canada, Australia, New Zealand, and Japan, we aren't close. In other words, the targets that our countries have set are far too weak. And if that's all we do between now and 2030, we have no hope whatsoever of doing our fair share to meet the Paris 2-degree target. So we've got some challenges in Australia, we've got some challenges in New Zealand to ramp up action on climate change really quickly. Now we do have an opportunity to do that because the Paris Agreement says that countries will periodically review what their targets are and revise them, hopefully with more ambition. The way we scientists tend to assess whether a country is doing what it should be doing or not is this very simple idea of a carbon budget. Everyone understands what a budget is. It's how much you can spend until your budget is exhausted. Every company must know that. Well, this is a carbon budget for planet Earth, and it's based on this very nice relationship between temperature and the cumulative amount of carbon that you burn since the Industrial Revolution. So if you look at a 2-degree, there's the Paris target, and look at this line, which there's a bit of uncertainty around it, you see that you have about 1,000 billion tons that we can emit. For the 1.5, it's quite a bit less. It's about 650 or 700. So if you look at where we are now, that's that 1,000 billion tons. We've actually burned more than half of that since the Industrial Revolution, 565 billion tons. And you can do the sums pretty easy. 435 billion tons are left in the budget. So you say if we burned over half, we should be a little bit above 1 degree, and that's exactly where we are. Current temperature is about 1.1 to 1.2 degrees above pre-industrial. So this is a very, very robust relationship, easy to understand. The thing is, this is only for CO2. So if we account, and this is important for New Zealand, if we account for the non-CO2 gases, it actually knocks the budget almost in half by another 210 billion tons. So if we do that and say, well, these are really tough because these are mainly agricultural, and say, let's focus on CO2, that leaves us with a budget of about 225 billion tons. until we can burn no more whatsoever anywhere on the planet. We're burning now at a rate of 10 billion tons per year. And again, you can do the sums. 22 and a half years before we have to completely decarbonize. So that's not when we have to start acting, it's when we have to finish acting. That's when we have to have completely transformed our economies. So you can see why scientists are getting really, really concerned about the complacency. There should be no complacency. We have no time left. So we've got to basically decarbonize the global economy in 2 to 3 decades. Now we can buy a little time if we get on top of this, and that's where I think New Zealand can come into the picture a bit more strongly. Because when you look at the New Zealand profile, you've really got to concentrate on that line in the budget, which is sort of pushed aside by most countries. And the reason you've got to look at it is because when you look at the contribution of the various gases to warming, which is the length of the bar there, we can see the top one is CO2. It's the most important one. But this is really important. This is methane. So it's not insignificant. So if we can find a way to reduce methane emissions, it would actually make a big contribution to the whole problem. This is nitrous oxide, not nearly so important as methane, but it's really, really long-lived. So you can't get it out of the atmosphere so easily once it goes up there. So these are the two other important greenhouse gases. These, by the way, are the ozone hole replacements. They don't affect the ozone hole, but they're pretty strong greenhouse gases, so there's a problem there as well. Anyway, let's focus on those two for New Zealand, because agriculture is the main source for both of these. For methane, it's wet rice cultivation, but it's cows, it's cattle. It's dairy cows, it's beef cattle, and so on, emit a lot of methane. This is mainly fertilizer, nitrous oxide from fertilizers from intensive agriculture. So in the New Zealand emission profile, these two are important because of the big agricultural sector in New Zealand and the big dairy sector in New Zealand. Very important for the economy here, but also a very big challenge. The other challenge New Zealand faces is in forestry. And that's sort of a complicated issue, but let me try to walk you through. This graph here has a zero line, and the two wedges above are emissions by humans into the atmosphere. The three wedges below are where does that carbon dioxide go? It starts from way back here in about 1870 or so. And you can see this enormous increase after the middle of the 21st century. The gray is fossil fuels, it dominates. This is actually important. This is land use change. This is deforestation. And it's net deforestation. It also includes planting trees. It's human action concerning the land. So when New Zealand plants trees, it actually reduces this wedge a little bit. But when Amazon is deforested, it increases it. So the dominant factors here are the Amazon and the Southeast Asian forests. This is uptake naturally by land, and it has to do with when you have a nice wet La Nina year, plants around the world grow better. As CO2 increases, they grow better too. Enormous variability from year to year. This light blue one is what stays in the atmosphere. This is what's going into the ocean. So the interesting thing are these two, emissions from land and emissions into land. So when we look at that from a scientific point of view, these two arrows go across that zero line. This is emissions from the land, but that's the land taking it up through planting forests, growing better. This is through fires, cutting down forests, and so on. And it oscillates naturally. Without humans, this is about in balance from year to year. The problem is we are putting new carbon, inert carbon, into the active system. So this is fossil carbon locked away in the ground for hundreds of millions of years. So the problem is the so-called offsetting issue. So scientifically, you cannot offset new carbon simply by changing the balance there. It doesn't work. The only way you can do that is by using this as an intermediary and then making an arrow here. This is the so-called carbon capture and storage issue, which still is not economically or technologically viable. So this is an issue for New Zealand, because as you plant forests here, several things could happen. Obviously, changes in land clearing policies. A new government decides, hey, we're going to cut these down, and the market looks pretty good. We're going to make some money out of them. The soil underneath the forest, and indeed under any terrestrial ecosystem, it actually respires more carbon as the temperature goes up. Very fundamental relationship. And we have natural disturbances, some of which are getting worse fires, insect plagues, as temperature increases. So climate is working against you keeping carbon in the land, and so are policies. This is an example of what's happened in Australia. This is a Tasmanian forest which had never been burnt. It was in a World Heritage Area. It's not a human forest, this is a natural one. And it was just devastated a couple of years ago, 2016, by a massive fire that went through it. And it was simply because it got too hot and too dry, outside of the normal environment that forest has evolved in. So this is the vulnerability of land carbon that we're looking at here. So the bottom line on land carbon, and this is important for New Zealand, is effective climate change policy must focus on fossil fuel emissions. We've got no time left to fiddle around with offsets. We've got to get carbon back into the land. It's a good thing, but you can't do it at the expense of getting fossil fuel emissions down. You've got to do both. So it is useful to get carbon in land, but just don't take the pedal off the fossil fuel action. And there should be no offsetting. You should put a policy firewall and an economic firewall between land carbon and fossil fuel carbon. That's not actually well understood. It got embedded in the policy world back at the time of the Kyoto Protocol. Against the objections of some scientists, we were writing papers even back then that you shouldn't do that. But we got rolled over by the policy people. Last thing I want to say is I do a lot of work in Sweden, as you probably guessed, because I'm with the Stockholm Resilience Centre. There's a really interesting analogy here, I think, between Sweden and New Zealand. Sweden's a long way from the equator as well. It's a small country in terms of population, very highly educated, very innovative population, and very active in doing something about climate change. So does this offer perhaps some opportunities for New Zealand? First thing is there was a carbon tax of $100 per ton put in 20 years ago, before most countries were even thinking about doing anything. Now the debate about that isn't whether they should have it, it's whether it should be $200 a ton. Basically what they've seen is the $100 a ton has driven the low-hanging fruit, the easy stuff to get down in emissions. Now they got the tough stuff, so they're going to put the price up. They're promoting wind and solar for renewable energy generation. I put some exclamation points there if you know how far north Stockholm is. It's in the dark basically 3 or 4 months a year. But still, it's economically viable to put in solar 60 degrees north. That tells you how cheap solar is getting. But there's another hidden message for New Zealand. Sweden has a fair bit of hydro. They've also got some nuclear, but they are diversifying their energy mix as fast as they can. It's going to be more resilient for them. If they have changes in precipitation patterns and the hydro becomes less important, they've got something else they can rely on. So it's an important lesson for New Zealand if you rely too much on hydro, and there are projections of rainfall in the long term dropping off in these southern mid to high latitudes, then you've got some problems. So it's important to think about energy mix and resilience of the energy system. Large forestry industry in Sweden, just as it is here, but they've never offset ever in their accounting and so on. They use it in a different way. They burn the waste from the forestry in small power plants dotted across the Swedish landscape, and they co-generate heat for district heating in the villages around them and for electricity, and they put it into the grid. That's carbon neutral because the forest waste they burn, of course, has grown and pulled CO2 out when it grows. Then when it's used in the power plant, it puts it back up. But it's a circular thing. So you might want to think about something like this for the New Zealand forest industry. The last one I want to say is this is a really tough nut to crack. How we're going to get aviation to be carbon neutral, because we can't electrify it like we can cars and trains. So we've got to do something else. And there's been a lot of talk and some research here in New Zealand, quite a bit of research in Sweden on how do you generate bio-aviation fuels that are carbon neutral. And the Swedes actually have moved forward with this. They've got plans to put refineries at their 3 big airports. There's not a timeline yet. They've got to do some more work on that. But their idea is in a decade or two to be able to fly all the Swedish domestic flights carbon neutral. So that takes the way any need for so-called offsetting. But this is a really tough one to crack. And a country that actually comes up with the technology has an enormous knowledge export. So is there a possibility for New Zealand to jump in and help work on this bioaviation issue? Last thing is Sweden's had bipartisan support from the beginning on climate policy, which is the way their political system works. When they get a really tough issue, they talk and talk and talk until they come to a common ground and then put a policy in. And then when the government changes, business has certainty, that the setting isn't going to change. The government may change, but the policy is not. And that's hugely important for business to be able to do the heavy lifting. So perhaps there might be some interesting analogies here with Sweden. Now, the last part of my talk, I want to spend a little bit of time here now talking about, as a Neurosystem scientist, how I view climate change and how my it's not really a discipline, my interdiscipline of Earth system science views it. So we don't look at climate the way most people are looking at it. We're looking at it in terms of a complex system. So you can see the complexity of ocean circulation at different scales, scaling up to entire ocean basins. And we look at all the factors, the processes on land, ocean, atmosphere, as a single system. And we have a lot of evidence that the Earth actually behaves as a single system. So when we look at climate change from an Earth system point of view, two things really stand out. The magnitude of the change, and most people don't get this. This isn't an environmental problem. You probably heard, I haven't used the word environment yet. So I get a bit annoyed when I go to my government and they say, oh, that's the Department of Environment. No, it's the Treasury, it's the mining sector, it's the transport sector, it's the foreign affairs, it's everything, because it's the planet you're talking about. So the magnitude, but also the urgency. I've already alluded to the urgency, but we're going to come back and hit on that again. All right, so what's happening globally? Well, the first thing you can say is that patterns of circulation are changing. So let's forget about whether it's going to rain more or less on South Island and look at the big picture. Circulation is shifting around the world. And we can see in the last half century how precipitation is changing. So the areas here that are brown is where it's getting drier, and the areas that are blue is where it's getting wetter, and the white areas, not much change. But you can see some patterns emerging really strongly. The reason this is important is that a lot of people depend on this. This is the Sahel, big population in West Africa. It's drying out. This one's a really big one. That's Northeast China food bowl, which upwards of 1 billion people depend on that. And this is what's happening to the Australian agricultural zone in the southeast. Definitely getting drier, definitely getting more difficult to grow wheat and so on. Indo-Gangetic Plain, very important for India. The one that's really biting now is the Mediterranean, where there's been strong drying around the Mediterranean, particularly around the eastern part of the Mediterranean. And that's being manifest already in problems there. But this is with 1 degree. That graph was with 1 degree of temperature change. And the shifts in the future are going to be nonlinear. So above 2 degrees, there are going to be massive changes in where rain falls and when it falls. And this is going to disrupt the global food system. And the expectation are that millions of humans are going to be affected. Migration now would be a trickle compared to this. Starvation will be a problem in places like Africa, where the people are already very poor, they have poor governance, they have no backup. We certainly won't starve because we have pretty robust agricultural systems, but we're going to have a lot of people moving around the world, and conflict is going to be a problem. So we see this already in Syria, that's Aleppo, and of course the conflict there is well known, and there are a lot of reasons for that. Iraqi refugees come in years earlier, very weak, dysfunctional government, which is actually a key factor here. But it's the worst drought in their recorded history. And a couple of million of Syrians have come into Aleppo and Damascus from the hinterland because they can't grow food. They have no jobs, they don't have much money, they're looking for food, and particularly a lot of the young males, it's a big problem because they're easy prey for ISIS or some of the other terrorist groups. So it's not a simple issue that climate change is driving this, it isn't, it's a combination of factors. But climate change is actually a threat multiplier, which is the way the military look at it. And this gentleman from the US military has summed it up in one sentence. He says climate change is like getting embroiled in a war that lasts for a century, and there's no exit strategy, you can't get out of it. So this sort of risk is not understood. I've heard the Australian military at the highest levels talking about it, but it gets expunged from any report the Australian government does on future security threats. It's all about terrorism. Well, listen, guys, there's some reasons why we have problems with terrorism. Climate change contributes. This isn't the only one, but it certainly contributes. So, what does this look like from a system point of view? I'll go back to this because this is about where many people's knowledge of climate change stops. But this is only the beginning of the story. We have to put this in a longer-term perspective. So what I've done here is taken a 2,000-year temperature record for planet Earth. So this is the Roman Empire here. Here we are today. And you see natural variability. You see the temperature going up and down. But these are very minor. These are a tenth of a degree. So you hardly notice them. And within very well-defined bounds. And we know why those bounds are there. We understand the interplay between the Earth's orbit and the amount of sun coming in. But look at this enormous spike at the end. That's the human change in the last 60, 70 years. So you can see it is way outside natural variability. And it's moving at an extremely rapid rate. So when you look at these rates, that temperature spike is about 170 times faster than any of the wiggles you saw. This is why coral reefs can't cope. This is just smashing them with completely new conditions that they have no time to evolve or adapt to. Same with that forest in Tasmania. Same with the forests up in Canada and Siberia, and so on and so on. CO2 going up into the atmosphere is about 100 times faster than anything we can see in the last several million years. So that's really, really fast increase in the atmosphere. The thing I haven't talked about is that CO2, that blue wedge on that graph I showed some time ago, CO2 going into the ocean actually reacts with water to form carbonic acid. And that's acidifying the ocean at a rate faster than anything it's seen in 300 million years. So this is now a big evolutionary hammer hitting marine ecosystems. Hardly ever talked about. But this is probably as important as the temperature rise in the ocean in terms of driving change. But these are Earth system problems. And this is why I say when you look at this in an Earth system perspective, climate change looks wholly different from what most people think. Well, here's the standard of projections for 2100. That's the IPCC models. Low emission there, high emission there. Doesn't look too bad. Those are fairly gentle looking curves. But again, you need to put them in an Earth system perspective. So if we use this same graph here with the 2,000-year perspective and put that on, it looks like this. So it's, again, an extremely sharp spike. So remember, this is 1900, 2000, 2100, looks like that. So this is why scientists, Earth system scientists, are exceptionally concerned about what this actually represents. We go back probably 100 million years with good enough records to interrogate, has this happened before? And we can see only 2 times in the last 100 million years when we've seen anything close to this, not quite as sharp as this. One was when the meteorite hit about 65 million years ago and wiped out the dinosaurs. That was a big shift in the opposite direction from all the dust thrown up. But then we saw a temperature spike about 56 million years ago. And that was a really interesting one because it was driven by carbon being shoved into the atmosphere from the ocean, from sediments. And we don't know what triggered it. That's still a mystery. But once it got going, it was unstoppable. And temperature got to be 5 or 6 degrees higher. And there was a mass extinction in the ocean during that time. So the Earth has seen changes vaguely like this before, and they haven't had good outcomes for the biosphere. So that's why we're really worried about missing the Paris target, which is there. So I think we're pretty much committed, and you have to be really brave to say we're going to make 1.5, because we're already at 1.1, 1.2. We have a shot at 2, because I'll show you in a minute, we got no time left. We got to act now, start acting now if we're going to get there. Of course, if we don't get there, we could go to 4, perhaps even 5, by the end of this century or certainly in the next century. And that's a huge challenge, not just for the natural world, but for humans to deal with. And some people think a worst case scenario is we could get a collapse of the civilization that we know today. So from Earth system science point of view, climate change looks very different than from the normal point of view. So the implications are, if we can meet the Paris target, there's a chance we can stabilize the climate and maybe slowly, over centuries and millennia, cool it back down. This is probably survivable, although it's going to be a rocky road. But I suspect we are clever enough and robust enough to survive that. Not everyone, not the poorer countries, but by and large will do this. However, the problem is, if you go much above here, there's a chance, a risk that you're not going to stop there. You're going to go all the way there. And that's because of so-called tipping elements in the Earth system, which may just put a bifurcation, a fork in the road. And once you start on that road, you don't get on this one. And the reason for that is these elements in the system, parts of the Earth system, that can change suddenly with a bit of a push. That's a tipping element. So they come as 3 different types. Biomes, that's big parts of the biosphere like the Amazon forest or coral reefs. changes in atmospheric and ocean circulation. And this one's getting really, really important now, and that's melting of polar ice, because that can really raise sea level, huge issue for a country like New Zealand. And the more we learn, the more we're realizing we actually should put another one here over in East Antarctica, because the biggest glacier there, the Totten, looks like it's much less stable than we thought even 5 years ago. So these are the sort of tipping elements that are there, and say, well, at 1 degree, is anything happening? The answer is yes. Amazon in the last decade has had 2 very big droughts and fires. It's lost a decade worth of carbon that's taken up. So we're getting extra carbon into the atmosphere from that. Permafrost, that's frozen carbon in the soil up in Siberia. That's starting to bubble out in small amounts at the moment, so it's not a big effect yet. But depending on whether we hit 2 degrees or go higher, we could lose quite a bit of carbon from that area this century. Remember that human emissions are about 10 billion tons, so that upper limit is about 25 years worth of human emissions of extra carbon. That in itself would blow the carbon budget. Remember, we had 225 billion tons for all of humanity till we decarbonize. If we destabilize this area in its own could blow the carbon budget. So these are big items in the Earth system that we're thinking about. Arctic sea ice, that's the floating ice. That's dropping off at a very fast rate, faster than the models predict it will. I think that's tipped already in terms of we're committed to lose it entirely in the summertime, probably in a couple of decades. And of course, we've said that coral reefs have tipped already. Polar ice. Polar ice is really important, Greenland and West Antarctica down here, because they're land-based. And if they melt, they raise the sea level. So the projections now are that there may well be a tipping point for Greenland that we could hit this century. 2 to 3 degrees, Greenland could tip. And that would mean eventually about 7 meters of sea level rise. You can imagine what Wellington would look like with 7 meters higher around that waterfront. It's not a nice future. And as I said, we're almost certain that coral reefs have already tipped. So these are big changes in the Earth system at 1 degree or so. And they are sort of saying, look, if you really want to push this system beyond 2 degrees, you're going to tip a lot more of those. And once you start tipping them, as there you can see, there's the Paris target. Several of those tipping elements sit there, but when you start tipping them, they actually push the temperature up to where you start tipping others. And you get what we call tipping cascade. This is typical of a single complex system, is it wants to exist in stable states, but when you start destabilizing it, it has its own internal mechanisms to move to another state. And we know that a 5-degree warmer world is very stable. It's been there for a long time. It'll eliminate all the northern hemisphere ice, and it'll eliminate roughly half of the Antarctic ice sheet. So the problem is you just don't want to get this thing going. You want to avoid that. So that's the difference between a 2-degree world and possibly a 3-degree world, is that tipping point may be triggered somewhere in there. So from an Earth system science point of view, there's an even better argument for the Paris 2-degree target than just, well, you have a few more impacts at 3 degrees. Well, you may actually tip the whole system between 2 and 3. The other thing that we Earth system scientists look at are long time frames. This is the last 10,000 years of a very warm, stable period that has allowed humanity to develop agriculture, settlement, civilization. But for any of the climate scenarios, this one just under this first blue line is the Paris 2. So that basically is the 1.5 to 2, the lowest one. But notice over 10,000 years, the temperature doesn't come back down. And that's because of the long-lived gases in the atmosphere. The fact that if we allowed nature to bring them down, they'll bring them down, but on the order of about 100,000 years, not 10,000 years. So wherever we land up here, we're stuck. So you got to think very carefully of what sort of world you want your children and grandchildren to live in, because generations into the future are going to be stuck with that. So it's the irreversibility is again, not talked about much, but this is a one-way road, people. We're not going to come back from wherever we set the climate. Now, the crunch. I hope I've convinced you don't want to go beyond the Paris target. That's really, really risky. So how do we make sure we don't? Well, again, we go back to this budget. And how do we cope with this budget? Well, let's look at our roughly 225 billion tons that we can burn. These are 3 different lines that all stay within that budget. But notice how sensitive they are to when you start going down. If we could have got going down last year or the year before, we have out to about 2045 before we completely decarbonize. And you can imagine 3 decades working hard. We could do that without too much economic disruption. It would be tough, but we could do it. But waiting till 2020, which is the next sort of fork in the road, that's this yellow one, we're going to decarbonize by 2040. Now we're looking at the 2.5 decade. That's tough. We might be able to do it. But if we miss the 2020 and wait for 2025, it's basically impossible. You've got to decarbonize in 1 decade. And it's just technologically and economically not possible. So this is why it's really, really critical that although the decarbonization time looks a little bit far out in the future, the time we have to commit to it, have a plan, and have policies is only 3 years, 2020. That's a term of a government, or even less in some countries. So it's hugely important that pressure gets put on now. You've got an opportunity in New Zealand. You've got an election coming up very soon. And as we've talked about with my colleagues at Victor, I haven't heard much about climate change from the snippets I've heard in the election. At least in Australia, it gets in there because energy is such a toxic issue, you can't avoid it. But here it's different because energy may not be such an issue with hydro and geothermal. But it's hugely important for New Zealanders to realize that every country has to do its share to get onto this yellow curve. And if we don't, it's going to be virtually impossible to meet that Paris target. A few closing comments then about what happens if we don't. What does a 4-degree world look like? Well, most of the tropics and subtropics are going to be too hot for humans. This isn't going to affect New Zealand, but it's going to affect a lot of countries to the north. And there are a lot of people live in them. We talked about rainfall patterns changing. Sea level, we talked about that. But at a 4-degree world sustained, the sea level is going to be eventually very high, 20 to 40 meters higher, drowning a lot of coastal cities. And maximum carrying capacity, there's a lot of debate about that. It depends on how resilient and clever humans are. And some people say we can survive even 4 degrees. But I think some of the more informed people say, no, we can't, that we can support maybe 1 billion. We're not going to support today's 7.4 billion and still going up. So my colleague John Schellenhuber at the Potsdam Institute, when you ask him what's the difference between the Paris target and business as usual, he only answers in 2 words. It takes him only 2 words. Human civilization. That's the difference. So he's pretty convinced that if we go much over 2 degrees, we're likely not to stop until we hit 4 because of the tipping points and feedbacks. And if we hit 4, it's going to be chaos as people scramble to be able to grow food, scramble away from cities that are being inundated and so on. Not a nice world. So let me just summarize then. What's the magnitude of the challenge? Well, a worst-case scenario, if things really go pear-shaped, it could collapse modern civilization. It's not a prediction, but I'm saying it's a possibility. So then it becomes, how much risk are you really willing to take? And I can just give you a little personal example from New Zealand when I was younger and climbing in the Southern Alps up around Cook and Hicks and Tasman and those mountains. Those are difficult mountains and they're quite dangerous. And if you see an ice shelf above you that has even a hint, a 1%, 2% chance that it might come down on a warm day, you spend an enormous amount of energy moving around it so you're not in the firing line. And if I would have taken in my personal life the same attitude that most governments are taking, I probably would have been killed many times over in the mountains for simply ignoring low probability but extremely high outcome risks. And that's what we're facing here. I don't know what the probability is that society is going to collapse, but I damn sure know it's more than a couple of percent. And do you really want to take that risk? And the second thing, urgency. Basically, we got 3 years left to get our act together. So this should leave you all with some things to think about in your business life. And I know you've got all sorts of more immediate things to think about, but take a little bit of time every so often to sit back and look at planet Earth and say, what can I do? What can we all do? What should we push our politicians to do to protect the state of this planet? So, thanks very much.
Wow, that's given us so much room for thought. And I know a lot of us have heard this before, but it's something we keep needing to hear. There's always something new to take from it. And I think we've got time for 2 to 3 questions. Has anyone got something burning?
I'd be interested in your thoughts on New Zealand's policy then for climate change, because even if we decarbonised our entire energy system, we wouldn't meet our Paris target. So what do you think we should be doing about our agricultural system?
Well, I had a discussion yesterday at the presentation of the ministries about that, and I think what you got to do is take seriously the fact that you're going to solve this. And that means you've got to put a lot more into research. You've got to find partners in other countries that are facing the same issues to partner up and do this. I think I heard the figure of 60 million being invested over I don't know how many years. That's far too little. It's not a case of, well, it's too expensive to do this. You need to change the mindset to say, if New Zealand's going to do its fair share, it's got to get on top of the agriculture, the methane and the nitrous oxide. And the answer there is, you've really got to put some serious intellectual muscle power into that and say, over the next 10 years, we're going to solve it, whatever it takes. That's what you got to look at it just differently and go for it.
Thanks, Will. That was great. Going back to Sweden.
Yeah.
It's a wonderful country. Lived there for 5 years, and I can completely see your point there in that they put $100 on these carbon emissions, thinking about 200. Where did that $100 or $200 go? Did they leave it then up to the market to figure it out, or did that $100 go into a fund in order to actually fund those solutions?
That's a good question. I'm going to ask Johan when I get up there. I think it went into consolidated revenue in the government. It got paid to the government, as all these taxes do in Sweden, but I'm not sure what they did with it. It's a good question, and I'll try to chase that up.
Any other questions? There will be a chance to, are you heading off straight away, or will there be a chance to chat with you?
I don't think we have to say immediately. I'll have to ask Kate. Yeah.
Okay.
And if you want a bit more for the general discussion, I'm happy with that too.
Sure.
It's up to you.
So I think what really landed for me there was about that this isn't just an environmental problem. It's really a problem that covers everything we do, and it's about the planet. From the SBC point of view, we're really trying to talk to governments about this. We've had Simon McKenzie from Vector, we've got Mike Bennett from Z, and John Nolan from NZ still working with Abby to talk to the different parties, and we're working our climate action groups together on collaborative action and setting goals. So that's what we're going with, and for our members, keep telling us the stories about what you're doing in this space. Carl, did you have anything that you... Oh, sorry, one more question.
Thank you. Yeah, I was just wondering, you talked about the carbon budgets for different countries. I'm wondering, I've heard a lot of talk about science-based targets for companies as well, and I'm wondering if that sort of carbon budget approach has been worked out to flow down to what responsibilities companies should have and how they should set their own internal goals?
Yeah, it's a good question, and my answer to that is downscaling is difficult because you can downscale simply by population and say, well, New Zealand's target is, its budget is the percentage of the global population that lives here in New Zealand. You could do something similar for companies, saying, what is your share of the GDP or something? All of those have their flaws. Nevertheless, it's useful for companies to think of some sort of target and then upscale. I like the upscaling idea, saying, if every company in my sector behaved like I'm behaving or planning to behave, what would our emission profile for the sector look like? The second point I will make is that there is a really important role for the business sector to take, and that's to influence your government as best you can in an appropriate way to get a bipartisan approach. Because ultimately, this is a collective action problem. Whether it's not a problem ultimately for individual people or individual companies. It's a collective action problem. And to get that under control, you have to have clear, long-term, consistent policy settings. And my colleague Jerry Houston in Australia used to be CEO of BP Australasia. He's originally from New Zealand. He's really forceful in saying the business sector, the private sector, has to do a lot of the heavy lifting here. But it can't do it if it's got policy flip-flops and it doesn't know if it can invest and that investment still be viable with a change of government. So it's important, too, that business play its appropriate role in getting to politicians and saying, this is much beyond being a political football. You simply have to come together, talk it out, and if the government changes, the critical policies on climate don't. So we can invest, we can do the heavy lifting, and so on. So I would say, even more important than downscaling and making a carbon budget for a company, it's getting the country together on a coherent approach, long-term pathway, so that over 2-3 decades, when you are going to invest in a lot of new things, new technologies, new infrastructure, you know you can do that with confidence. To me, that's the number one thing you need to do.